We are going to discuss about the example of superposition. For example, we have this question. Okay, use superposition theorem to find V. Where is V? V is here at 4 ohm resistor. We need to understand these following steps are required before we can proceed to analyze our superposition solution. Number one, we need to identify the numbers of independent sources. What independent sources? So in this case, we have this 6 volt, number 1, and 3 ohm, number 2, independent sources. So we have voltage source, we have this voltage source, we have this current source. Number 2, number of independent sources equal to the algebraic sum of the respective element. Okay, because we're being asked to identify V, and because we have two independent sources, it means that we are going to have V1 plus V2. This is what we call algebraic sum of V here. Number 3, our mechanism is to turn off our independent sources, whereby we can have our voltage source as a short circuit, our current source as an open circuit. Now, let's start with the first one. Case 1, turn off independent current source. So because it is current source, then what we need to do is we need to make it as an open circuit. So this is our original circuit, right? So what we need to do is, because we have this current source, then we make it as an open circuit over here. So what will happen? No current will be flowing through this section. Then we just have to concentrate for this side. If, for example, we applying KVL to this loop, we have this I1, right? So straight away we can write 12I1 minus 6 equal to 0. Why 12I1? Because 8 ohm, plus 4 ohm for I1 minus 6 equal to 0. Then we can easily obtain I1 equal to 0.5 ampere. Then we can write our V1 over here. You must remember this is V1 because we are dealing with algebraic sum. So V equal to IR, which is equal to I 0.5 and your resistor equal to 4. Then you have to vote for V1. Remember, this is only for V1. We are not done yet because we just finished our case 1. Now we are continuing with case 2. What is case 2? Because we have another voltage source, so this is actually not open. We need to make it as a short circuit. You must remember voltage, okay, short circuit, current, okay, open circuit. So this is the original circuit. So you see this is your 6 volt. Now we turn it into short circuit. Okay, we remain our values of 3 ampere over here. Now, due to this circuit, so we have this part, okay, as well as this part. So you can use, for example, current division rules for you to obtain what are the values of I3 over here. Okay, you can use this formula, I3 equal to 8 over 4 plus 8, 8 over 4 plus 8, okay, multiplied with 3, which is the I total, then you can obtain 2 ampere for your I3. Then, because V equal to IR, then your current just now is 2 and your R is actually 4. Then you can have 4 volt for your V2. You see, just now what you have here is your V1 and here is your V2. So your V equal to V1 plus V2 equal to 10 volt. You must remember superposition is about algebraic sum, meaning that you need to accumulate the values because you have two independent source. This is why you have V1 plus V2. Okay, I really hope that you can understand the concept of superposition. The problem with superposition, you must be able to imagine if you have more numbers of sources. Let's say you have 5, then you must have V1 plus V2 plus V3 plus V4 plus V5. So this is why we also need to understand that superposition sometimes is not a very practical solution. Why? Because you need to repeat the processes depending on the algebraic sum of your elements. Thank you.